two nations stood only a few miles apart, close enough to see each other on a clear day. Yet for centuries, that narrow stretch of sea felt like an impossible wall. People dreamed about connecting them, but every serious attempt ended the same way with failure. More than 200 years of ideas, plans, and abandoned projects convinced almost everyone that nature had already made the final decision. So, what made a group of engineers believe they could succeed where everyone else had failed? What gave them the confidence to dig deep beneath the seabed, knowing that being off by just a few feet could unleash millions of tons of seawater and wipe out the entire project in minutes? This wasn't just another construction job. Every step forward meant betting against the ocean itself. One mistake could cost everything. And somehow, they kept going. But believe it or not, that was only the beginning. The English Channel has always been one of the busiest shipping routes in the world. Every day, thousands of ships crossed those waters. But people kept asking the same question. What if there was a permanent way to connect Britain and France? At first, the answer seemed simple: build a bridge. But the more engineers studied the idea, the more impossible it looked. The water, the weather, and the heavy ship traffic made a bridge far too risky, so the focus shifted underground. That idea wasn't new either. People had been talking about a tunnel since the early 1800s. There were plans, surveys, even test digging, but every attempt ran into problems and eventually stopped. After more than 2 centuries of setbacks, both governments finally reached the same conclusion. If this connection was ever going to happen, they would have to build it together. Once the project was approved, the scale became clear. This wasn't going to be a single tunnel under the sea. The final design included 2 rail tunnels, one for trains traveling in each direction, and a third service tunnel running between them for maintenance and emergencies. Construction started from 2 different places. On the French side, workers launched from Sangatte. On the British side, they began near the famous White Cliffs of Dover. The goal wasn't just to build another piece of infrastructure. This project was meant to create a permanent connection between 2 countries, making travel, trade, and business faster than ever before. It was an engineering challenge unlike anything either nation had attempted. And the hardest part was still ahead. The biggest challenge wasn't the distance. It was the ground hiding beneath the sea. Engineers had one narrow layer they needed to stay inside, called chalk marl. It was strong enough to support the tunnel and dense enough to keep most of the water out. But there was almost no room for error. If they drifted just a few feet too high, they could break into porous rock filled with water. If they went too low, they would hit sticky clay that could slow down or even trap the boring machines. A mistake that small could stop the entire project. That's why they spent years studying the seafloor before digging even started. Every survey, every sample, and every measurement helped map the safest route. Only after they were confident in that path did they begin building the tunnel entrances on both sides of the channel. With the route finally set, it was time to send in the real workhorses. The project used 11 tunnel boring machines, and these weren't machines you could simply order from a factory. Every single one was custom built for this job. Each weighed thousands of tons, with a massive rotating cutter head designed to chew through solid rock day after day. But digging was only part of the process. As the machines moved forward, they also cleared away the broken rock, installed heavy concrete tunnel segments, and sealed everything to keep water out. It was like watching a moving underground factory. Everything had to happen at the same time, without stopping. These machines weren't just building a tunnel, they were creating a safe path beneath one of the busiest stretches of water on Earth. Digging under the channel was never just about cutting through rock. The working conditions pushed people and machines to their limits. On the French side, the ground was wetter and less stable, so engineers had to keep pressure inside the tunnel to stop it from collapsing. Deep underground, temperatures could climb to nearly 50 degrees Celsius, making every shift exhausting. Even a small leak was treated like an emergency. Water seeping through the rock had to be sealed immediately by injecting grout into the surrounding ground. If they waited too long, that tiny leak could turn into a flood capable of trapping an entire crew. Every foot they moved forward came with real risk. Down there were no second chances. Every meter had to be earned, Keeping the tunnel on the right path was just as important as digging it. The crews couldn't rely on GPS this deep underground, so they used highly accurate gyroscopes and laser guidance systems to stay exactly where they needed to be. The operators steered these giant tunnel-boring machines with incredible precision because drifting even a few feet off course could ruin years of work. At the same time, they had another huge problem. Millions of cubic meters of rock had to go somewhere. In total, about 7.5 million cubic meters of material were removed. On the British side, much of it was dumped into the sea, creating an entirely new stretch of coastline. The tunnel wasn't just changing what was underground, it was actually reshaping the landscape above. Then came the moment everyone had been waiting for. Two teams were digging toward each other from opposite sides of the channel, but they couldn't see one another. They had only their instruments and calculations to trust. After months of non-stop work, they drilled a small pilot hole through the final wall of rock. It worked. The two tunnels met almost perfectly. The final alignment error was less than half a meter after nearly 39 kilometers of tunneling beneath the sea. It was an incredible achievement and proof that every survey, every measurement, and every difficult decision had been worth it. That breakthrough wasn't just an engineering success, it showed what people can accomplish when precision and determination come together. Once the digging was finished, another question came up. What do you do with machines that weigh thousands of tons deep under the sea? On the British side, the answer was simple. They didn't bring them back. The tunnel boring machines were too large to turn around, and taking them apart underground would have cost even more time and money. So they were sealed inside the tunnel forever. On the French side, things were different. Their machines were designed to be dismantled and lifted back to the surface. But finishing the tunnels was only half the job. Crews still had to install the railway tracks, electrical systems, ventilation equipment, and communication cables. Only after all of that was complete could the tunnel begin to look like the transportation link people had imagined for generations. Building the tunnel was impressive, but keeping people safe mattered just as much. High-speed trains run through the tunnel using a 25,000-volt electrical system, so every part of the design had to reduce risk. Powerful ventilation fans constantly move fresh air through the tunnels because poor airflow could quickly become dangerous, especially during a fire. That's also why the project included a separate service tunnel. It wasn't an extra feature. It was the lifeline. Every 375 meters, emergency cross passages connect the rail tunnels to the service tunnel, giving passengers and workers a safe escape route if something goes wrong. That three-tunnel layout turned out to be one of the smartest decisions made during the entire project. It wasn't just built to move trains, it was built to protect lives. When the tunnel finally opened, it was clear the engineering challenge had been conquered. But the financial story was much harder to celebrate. The original budget had nearly doubled, turning the project into one of the most expensive infrastructure projects of its time. Even more heartbreaking, 11 workers lost their lives during construction. Then, in 1996, one of the biggest fears became reality when a fire broke out on a truck shuttle inside the tunnel. Thankfully, the safety systems worked exactly as planned. The fire was contained, and the service tunnel allowed everyone to escape safely. Later, with the completion of High Speed 1, trains could travel between London and Paris in just over 2 hours. What once seemed impossible had become part of everyday life. The Channel Tunnel is much more than concrete, steel, and railroad tracks. It's proof that some of the biggest challenges in the world aren't solved overnight. They take patience, teamwork, careful planning, and thousands of small decisions made the right way. For more than 200 years, people looked at that stretch of water and saw a barrier that couldn't be crossed. Today, millions of people pass beneath it without giving it a second thought. That's probably the biggest lesson of all. The things that change the world rarely happen because of luck. They happen because people refuse to give up, keep improving, and make one smart decision after another until the impossible becomes real.